So just to begin with, right? Anybody heard about this LLM fine tuning? Anybody? So this kind of POC we embarked upon for a certain client because he requested for this. So his requirement was, I mean, generally, right? We have these LLMs or ChatGPT or Gemini, right? So they come with certain expiry date. That means they have the information up to June 2025 or July 2025, right? They have a cutoff date of their knowledge base, right? So likewise, when we take any of the models that are there in the public domain, right, they have only public information. Suppose a particular organization, say they have 30 years of history or 20 years of history. They want the ChatGPT to learn all the 20 years of history, right? So that's where you need to use the LLM fine tuning. If you have very little bit of information, right, then you can use the RAG architecture and get the information and pass on that information to LLM so that it can fine tune the answer. But if you have 30 years of history and you have millions of documents, right, the only way to update the knowledge base of LLM is to by doing the fine tuning. Okay, so this is all about fine tuning. If anybody worked on the data warehousing platforms, right, when we started data warehousing project, first we need to do the historical data last 20, 30 years or 10, 15 years, whatever that may be. So once you load the historical data, then only you will make that product live and it start loading the data from that current data onwards whenever it goes live. So it's kind of a historical loading of the data into LLM. So that's what it is, LLM fine tuning is. So the core concept is you are going to take the existing pre-trained LLM. Okay, then further train it on smaller domain specific data sets. So generally, most of these models comes with the generic knowledge. So if you want to train that on a specific domain, right, like finance or healthcare or education domain, right, so that it gets more knowledge in that domain. So the only way to do is to give the uh, you have to update that LLM using fine tuning technique using those documents. So the goal is to make sure that the LLM get to understand what is the niche vocabulary, because if you could look at the medical thing, right, it has a lot of very niche vocabulary, but the generic LLM doesn't have that kind of a vocabulary. So for that, you need to train using your vast medical history, medical documents, and also if you want to adopt a particular style of answering, right, for that also you can train with certain examples. So the analogy that I gave we gave here is, so and a graduate can come with the MBA degree, right, fresh out of college, but you have to give a specific job training so that you will understand the culture nuances and the inner working of the organization and specific IP that it might have, specific working rights, uh, specific working style, any frameworks, any process methodologies, all those things that person is going to get trained in there during the internship period. So that's what we are doing here also in LLM case. So most of these things are what we discussed. So task specialization. So example that we gave is a generic model might write a generic sales email, but a fine-tuned model, right, perfectly matches your company's successful sales framework and product value propositions, right? So whatever the document that you have, you can give it so that going forward it will use those things for any of the reply that it needs to give. I mean, domain adaptation that we discussed, right? So heart attack is called as kind of a myocardial infarction, it seems. Okay. So that's kind of fine tuning that you need to do, because if it has to do a medical transcribe, right? It cannot write heart attack, but it has to write these kind of words. So increase the reliability. Since you are going to train on your particular documents, right? So the hallucinations will go down drastically, and efficiency also would increase. You can get the answers with a very short, simple prompts instead of giving a lengthy prompts. So this is kind of a advantage that you go get when you fine tune a model. So just for your understanding, right? I just gave an example. So if there is a software company called Pixel Perfect, and if that person asks certain question like how can I enable dark mode in a Pixel Perfect app, then it will give a very generic answer before fine tuning, right? So it just giving based on the most applications knowledge that you have general from the general knowledge, right? So probably it could have a setting in say option in setting, then display option, then theme tab, etc. But if you have fine tune your model on on your company's documents, right? Then it will understand there is a pixel perfect tab within the organization and what is its setting could be, uh, so that it could give you the perfect answer. So it's saying that I can help with that in pixel perfect tab. So and so you need to do so that you can do that. So this is how the fine-tuned LLM would behave. So when to fine-tune? So this is the most important thing. Okay. So if you want to ask very simple and guided with instruction, right? Generally, what we do most of the times with ChatGPT, right? So in that case, you will just use the prompt engineering, what we are doing in our daily life. And the second thing is RAG architecture, which I mean most of the organizations are trying to use, right? So you will process the document, vectorize them, store it in a vector DB. Then when a user gives a question, then it will try to convert that into vectors, then match whatever there is in the document, then it will retrieve the matched documents and give it to the LLM so that it can answer it. But if you have to do the fine tuning, right? Then you have to have the large amount of data sets so that it learns the history. And also, if you want to change the behavior of it, right, then you can change it using those fine tuning techniques. So here the example we gave is draft a legal contract for a software license agreement, right? So this requires a specialized knowledge of legal structures. So a perfect case for fine tuning. So this is kind of a high level workflow. So what is that you want to achieve? You have to have the objective as to why you are fine tuning, right? So you want a chatbot that can answer support questions about our software. Okay. Then you have to prepare the data. This is one of the most important things. So of course in the demo also we are going to show it. So you have to structure in such a way, right? So you have to give some kind of an example. So it's going to take the document and convert into question and answers when you are trying to fine tune it. So it's called JSON-L. We know JSON, but here we have to use JSON-L kind of a structure. Then you have to select model and method. So here we are in this example on the demo that we are going to do, right? So we used server model. Server is a indigenized uh, model for India. I mean, in fact, Indian government sponsored to develop that model. So Servam is the foundational model which we used to do this POC and run the training process. So training process is not so easy. It is complicated. So which Suyash is going to show. Then of course, once that is done, then you are going to evaluate and iterate and retrain if required, adjust the parameters, all that stuff. Okay. So key methods at a glance. So there are a couple of techniques. One is full fine tuning. Full fine tuning means you are going to um, update all the parameters, billions of parameters, okay, which is going to be time consuming and it's very, very, very expensive. For at least 90% of the use cases, it's not required full fine tuning. Okay. But if at all it is required, right, it could be for large R&D organizations, right? So if they want to invent new things, right, the only way you can do is you have to really, really load all the data, and it may not require the general knowledge, right? So in those cases, they will really use that for R&D purposes or to invent new things. So in those cases, full fine tuning is used. So in my understanding, right, and wherever I heard, most of the cases I see in the medical field. So that's where they are trying to do the full fine tuning to invent the new discoveries, new drugs, especially. And PEFT is the most common method that you use to do your training. So this will impact only small additional parameters. So in the diagram also, so the blue one is are the ones which are uh, which we are not going to touch, but the only the yellow ones, right, which we are going to touch and fine tune them. So that is how uh, we are going to do in our demo also. So PEFT is the most popular technique. We will go into details about this later, but these are the two key methods. So preparing for success. So data pre-processing is the most important step. So in this slide, maybe you are going to spend 70-80% of the time in data pre-processing only. So once you have your structured data ready, right, then you have to just load the data and let GPU do its work. So you can go back to sleep, maybe get up next day if you are doing full fine tuning. But if you are doing tuning with only 500 GB or 1 terabytes of data, maybe it will be done in 20-30 minutes or so. Again, it's going to depend upon what kind of GPU you are going to use, right? So data cleaning and filtering, which we already know most of the cases in our regular projects, also will try to do that. Then formatting and structure, I told you, right? JSON, L. So the document is going to convert in this format. So user asks, I can't find the export button. The response could be, what should answer? The export button is located in file menu at the top left. So it will create the structure based on the document that you supply. Then tokenization, which we most of us know what that is. Then data splitting. You also have to, in a typical machine learning model, right? How you do the training set, validation set, right? So you have to split the data that you have into training set. Then once that is done, then the validation set. So you can use that to check the training progress. So then the test set. So once everything is done, then you can use the test set to validate your model output. So there are a lot of other topics that are going to come up, like technical components, fine, fine tuning, bias, and all that stuff, right? But before I do that, right? So I want Suyas to demo his solution so that you understand. So that will give a good context to the coming slides. So Suyash, over to you. Suyash, you are there, right?
Yes, sir. Thank you, Shri sir, to give me such a opportunity to present my demo for this type of stuff for fine tuning on a given data set. Here now I'm sharing my screen to present my demo. Here you can see that uh, I am just running live comparison on a given query because it is taking some time for demo purpose. I also computed some questions before this demo. I can show you I selecting the query as I fine-tuned server based model on a given PDF about data scientist at work. This is the title of that book, and now I am selecting like this type of some pre-computed question as I selected like this question: How did Raylan Newman describe Airnav's data team evaluation? And just click on the pre-computed button, and you can see here that I asked about that how did William Newman describe ANF data aggregation, but what my base model is giving because it doesn't know about the context of our PDF, so it just generates a generic response that data teams at a startup typically evolves for small groups to large, more specialization teams as the company grows, like a general generic answer by given by this base model. But when I fine tune it with our this PDF, then our output is enhanced like this. Like it generates that Euler Newman describes ANF data consideration. It is most context oriented and also know about the context of that PDF. Like I am asking about the query from that PDF, and I just want to know about that context So for this purpose, we have to do fine tuning our model. Just I am going to my code base and show you how I implemented it. Like this is my notebook at Google Colab, named as LoRA fine tuning. You can see here, I just installed some required libraries like PyPDF2 for PDF extraction and Hugging Face for model uploading from Hugging Face. And these accelerate and torch are the predefined library as Python for fine tuning purpose. And after this, I am just mounting a drive to save my fine tune model in future. I just imported some required libraries here, and after it, I am just making a cell for extracting text from that PDF, which I will be uploaded. And this is all about PyPDF2 because PyPDF2 is a very good library to extract text from a PDF. After it, I just give here some QA pair because you have to know about it that when you are fine tune model with a PDF, we have to know about context, like what type of query you will be asked. For that purpose, I am giving this QA pair that I will ask such type of query and I will want this type of answer from my PDF as a response. And after this, I am just loading my PDF from my local directory. As you can see here, I am saving data structure data scientist at work.pdf to data scientist at work.pdf in my notebook. And after this, I am just run this cell, which I told you earlier, this cell here for extracting text from my PDF. It just shows the output as 349 pages are there, and I am creating 356 training examples here. Training examples are just like a QA pair. And after this, I am loading my server base model from Hugging Face. This is you have to load a model in tokenized mode because loading a model as whole will be more costly. And one thing I have to tell you that I am using A100 GPU, which is most powerful GPU in Google Colab. After it, I am just loading that loaded that model. You can see here. And after it, I am just setting my training argument. In training argument, some key points are very useful, and we have to very sincere about it. Like we have to set epoch. Epoch means just like iterations, and we have to define a very good learning rate because very small or very large learning rate can take time or uh, may our model overfit, which is not good for our context. After it, I am just tokenize that model. You can see here mapping is happened in 356 training examples which I told you earlier. And after it, I am setting up my LoRA technique. LoRA technique is abbreviation of low ranking adaptation. It is the base technique for fine tuning. Here we only train less than 1% of parameter from whole parameters of our model. Here you can see that when you see whole parameter of our model, it is about 2.5 billion, but we are only training 3.2 million training parameter, which is about 0.1% of our whole parameters of our base model. After it, I am just this is again I think. After this, I am just starting training of this model. I am using this tool for fine tuning. You can explore about it. WandDB.ai. From here, I just access a token and run our just executed itself for fine tuning. Here, I set three epoch and it takes less time because my PDF is too small, about 2 MB. It fine tuned in about 4 minutes, and these are the training laws in each iteration. You can see here. After it, I just saved that fine tune model in my mounted Google Drive. You can see here the output, and now I'm testing my fine tune model. If there is any error, it would generate some error uh, as output, but there is no error. So just running the executed this cell very good. And after this, I am just asking some specific question from that PDF as a demo of that model, and I got some good responses. So I just verified that my fine tuning is happening very fine. And after this, I am just creating some demo to present here. Like I have to what is happening or not. I am just checking it and verify it with the help of digital. After this, I am now moving to deploy it on Gradio, which I show you earlier. Here I am just checking up that how much of GPU I have available, because I have to load both models. I have to upload base model and also fine tune model, because I have to compare both responses. For that purpose, I just checked about the GPU memory, which is about 40 GB with the help of 800 GPU. After this, I am just installing same libraries to load the fine-tuned model and base model. Here you can see here for comparison, for memory efficient comparison, I am loading server base model and also server fine-tuned model. And this is all about loading that model and tokenizing them for the response. This is all about that. Here you can see that GPU is detected, A100 is detected, and total GPU memory is 40 GB. And after this, I am just evaluated these responses with the help of server base model and fine tune model. And I just give hard coded it, because for demo purpose, we have to hard code some things, because in fine tuning, when you want to respond uh, of any query, you have to wait for some time, because we have not that much of computation here in the industrial purpose, in our enterprise purpose. We have to buy some GPU from NVIDIA for speed and accuracy. But for now, I am just hard coded these some question answer. But I uh, also done this live compare in my demo. You can so, and I just this is just adding this Avian logo in my front end, and this is first all about interface, which you will see in my demo. And after this, this is all about front end part. And now I am running my Gradio interface, and you can see here that this is my interface which I can access through it, and it is here. And you can see here now I am running a live compare. Here you have to wait for some time, like about 60 to 70 seconds. I am running this query, like I am just selecting this query and go for live comparison. It will take time, because I am retrieving response from both model, from server base model and server fine tune model both. And now I am when still executing, I am showing you that what is the purpose of fine tuning, that it improves accuracy. Before fine tuning, you have get a generic response, and after fine tuning, you just to see the result. Uh, when I asked about digital participation as a chief data scientist, it is a generic response. You can verify it, and it is a some context oriented response which is retrieved from that PDF. You can see here that it is a generic response, and it is a context oriented response. And I am now going that how fine tuning improves the things, like in in context of accuracy, in context, in relevancy aspect, and in business value. Like before fine tuning, you will get a generic response because our model is don't know about our specific data set, and after fine tuning, you will retrieve the exact codes and page references. Also, you can train your if you fine tune your model with these type of structure in JSON. After it, in context, because our base model is having no book knowledge, and after fine tuning, it is having a deep book understanding, because fine tuning is just like adding some more data in the base knowledge of our model. We are changing some weights there in fine tuning. Weights are nothing but as a parameter. Relevancy, before fine tuning, you get some vague responses, and after fine tuning, some specific and detailed answer are there. And in business value, just like a basic chatbot and domain expert chatbot, if you are fine tune your own model with your own data set, it will be a domain expert assistant like. But if you know fine tuning or this type of technology, then that is just like a basic chatbot. It is all about my demo. Thank you, Green sir, for giving me this such opportunity to present my demo here. Any
Yeah,
question?
so somebody was pinging some question, right, in the chat.
What is question, sir?
Hi, Srinivas sir. Akash here. Uh, hi, Suyesh.
Yeah. Hi.
Thank you so much for this demo. Very, very helpful. I just have
Okay.
one small doubt.
Okay.
This is the first time I've seen fine tuning in action. So really,
Okay.
thank you.
Okay, sir.
Appreciate it.
Okay.
Just
Okay, sir.
one question. In the before part, are we doing RAG, and
No, no.
in the after part, are we doing it? So what is it that we are doing in the before part?
Okay, sir. I am telling you. In before part, I am don't giving any context here. I am just load base model and ask some query. I am just loading the base model because
So
the
that
base
is the
So it
model.
model
does
that is
not have
available.
RAG context also.
No, no,
Yes,
no.
sir.
It's
We are
just a
not
base
doing
model
RAG
that
there.
is
Okay.
available on the public domain.
Okay. So its
We
base
just
model is
download it on
relying on
server.
its trained data. Okay. Got it. Got it.
Yeah, yeah. It's a base model that is made available by server. So that's the original model, what we are calling it as, and fine
Right.
train or
And
fine tune.
okay, sir. After fine tuning, I am just defined a format of our fine tuning. As you can see there, I am just defined QA pairs, because you have to very clear about your objective, that what type of purpose, for what purpose you have to fine tune. Like here, we have a purpose of Q&A based. So I just give some questions and answer to my fine tuning step, that I will be asked this type of query in future. So give me
Got
response
it.
like this. In fine tuning, one thing is
Yeah.
also happening. In RAG, you have to fetch a whole document. It will takes time, but in fine tuning, if you have computation, very well computation, you will get response in very quick time, because in fine tuning, the mo- uh, the the PDFs and your context data set is just colline with just aggregate with the knowledge base of exact base model. It is here. Like I am just loading server, and now I am adding this book in the knowledge base of this server, and just known as a fine tune. Are you getting?
Yeah. And so you mentioned that the data would co-align with the model, and in RAG also that happens, right? Because I think I was reading somewhere chunking would take place, and then you would vectorize it.
Yes, sir.
So
But
In,
so
no.
Akash, what you need to understand is that model, the data is outside of the model, right? In RAG architecture. Here in
Got
fine
it.
tuning, you are giving the information to the model itself, so that it will train. It is trained on that thing. So there's no need of any RAG architecture. From now onwards, you have to just query the model directly once you do the fine tuning, right?
Understood. So we don't have to invest in any extra vector database also, right?
yes, sir.
Nothing.
No
In
extra money. Yeah. Okay.
Only the
in
question answers, the answer it's going to retrieve is directly from the model.
From the model itself. Okay, very nice. Thank you. Thank you, Srini sir.
okay, sir. In RAG, you have to just perform some cosine similarities, like you know about if
Right.
cosine similarities. You just retrieve answer in basis of that similarity. But in fine tuning, model have the knowledge of that PDF or that knowledge of that data set. No,
Correct.
no similarity response is not there. Only the response from that model because model have know about that knowledge. Okay, sir. Thank you, sir. I
Got it.
think
Yeah. So anybody has any other questions?
Yes,
Because
yes.
this is the time to discuss. Okay.
Okay, student.
Yeah. So once this is done, then we can discuss further on that. Hopefully, the next part of the deck would cover that. Okay. So just moving on, right? So the key technical components. So fine tuning, right? So he used some of the functions. I don't know. I mean, he went a little bit fast there, but the hyperparameter is one of the crucial things that you need to understand and finalize. I mean, again, we are not going to get right at the first shot. You have to really experiment and tune it and run multiple times to see how best it performs for which kind of parameter values. But you will start with certain base and then start fine tuning it. So the learning rate is the first thing that you need to fine tune. Okay, so I just wrote what is learning rate is. Okay, I mean if people are deep into machine learning, people knows what is this learning rate, right? So, but before going to learning rate, right, the most important other function is loss function. So loss function is nothing but what is the actual value that model generated and what is the expected value that you are expecting, right? So the difference between those two is loss function. So it measures how wrong the model's predictions are compared to the correct answers in the data set. That is a loss function. Okay. So the learning rate, right? It tries to optimizes that loss. So that is the whole use of learning rate. But if you give the higher learning rate, right, it might overshoot the minimum of the loss function. But if you give the low learning rate, right, it might take a lot of time to come to that optimal point. Okay. So that is the learning rate. So another important point that we need to understand is weights and biases, right? So these are the parameters that you will use to learn. Okay. So people who know neural networks, right? So they know these weights and biases. So these are the fundamental for learnable parameters. So what are weights? There are numerical values associated with connection between neurons. So this diagram, I was not able to fit it there, so I put it in the next slide. But this is a neural network. So the weights, so that is the uh, weight is the value that carries between one neuron to another. Okay. So it's a value associated with connections between neurons in different layers of a neural network. Okay. Each connection carrying an input from one neuron to another has a unique weight. So their role is it determines the strength and importance of each input signal. The higher weight means the input has a stronger influence of, on the output of the next neuron, while lower weight means less influence. So just for us to understand, right? So we just gave an analogy. In a voting system where different voters have different levels of influence, the weights are like the influence scores assigned to each voter. Okay, but I mean, in our democracy system, this voting, every vote is same. But in especially if you are voting for in a particular company's general meeting, right? Some of the shareholders would have a higher influence. Okay, so their vote would carry more weightage. So that's weights. And another important thing is biases. Okay, so there is certain threshold that it needs to follow. when it is giving an output. So that is nothing but bias. Okay. So if you look at the analogy, right, in the continuing the voting analogy, a bias like a predetermined opinion or a baseline that a neuron has, independent of the incoming votes. So it has certain opinion. So it will use that opinion to control overall output. So weights and biases, they work in tandem to give the output. So that's what the weights and biases is. And the learning rate would influence these weights and biases. Okay, that's what it is. So another important thing is epochs. So that is the learning rate. So next is batch size. The number of training examples the model looks at before making an adjustment. Okay, so it could be 3 or 4 or 5, right? So depending upon the model and the model size, it will make that change. A large batch size is like getting feedback after a group project. A smaller batch is like getting feedback after every single math problem. Okay, so that is the analogy. Batch size. It's a singular larger size depends on the model size. The epochs is number of times the model will go through the entire training data sets. So analogy is an epoch is like reading a textbook from cover to cover. So to learn it properly, so generally the epoch will give 3 or 5 or 3 or 4 or 5, something like that. So it will read end to end. To if epoch is 3, it's going to read 3 times. So that's what it is. Okay, so these hyperparameters are important. So this is a typical range that we generally give. So we also experimented with multiple values, epochs, learning rate, rank alpha are a little bit more complex, which I'm not going to cover. And dropout is overfitting. We need to avoid the overfitting. So this is another important thing. Preventing overfitting. Okay. So what is overfitting? So overfitting is nothing which is trying to memorize. It's not generalizing, but it's trying to memorize. So mugging up and warm and giving the answer. But if you give a new data set, right, it will fail miserably. So that you want to avoid. So that is what is dropout rate that you need to define. So it will drop out certain percentage of new neurons so that that overfitting is avoided. So these hyperparameters and all that stuff, right? It in itself is a subject for a couple of hours. So, but this is the high level overview, so that if you understand, right, it would help. If you want to deep dive, there's a lot of mathematics behind it. You can definitely go to YouTube and learn it. Okay. Those are the hyperparameters. Then loss function, which we already covered. Then optimizer is some of the algorithms. Adam is one of the popular algorithm that we use. So to optimize the overall performance of the model. Okay. All these things we covered. So real world fine tuning challenges. So we ourselves faced a lot of challenges, and I just asked around the people who did in their organizations, right? What kind of challenge that they face. So these are the things that they came up with. High quality data is very sparse. Okay, I mean that's a struggle. We all know that in the organization how the data is so much messed up. So annotation is expensive. Manually creating high quality question response pairs, right, is time consuming and costly expert task. So I mean, for us we gave that those 10 questions, right? So it took almost an hour for me to come up with those 10 questions. So imagine if you have to give hundred or thousands or 1 lakh questions. So it's going to take a lot of time. So since ours is a simple thing, you are able to do that. But imagine if you are going to do this for very complex subject area like in finance or medical field, right? You really need a lot of uh, question and answer sets and proprietary data integration. See this data that you are going to get, right? So it's all over the place. So you have to make sure that it doesn't have privacy information and other security related information. So all those things you need to remove from the data. So removing that is going to be really, really challenging. And technical implementation hurdles, right? So this is another famous term, catastrophic forgetting. So if you train the model with the new data, right, it could possibly forget the other information that it has. So that's the reason you need to go and check periodically once you are trying to train the model, right? So the original question and answers, you need to use that as a testing so that when you fine tune the model, whether it's giving the same answer or not. Hardware and memory limits. So for the just 2 MB data itself, we spent around $10 GPU. Okay, so imagine doing that for millions of records or millions of data sets. Hyperparameter automation, it's both art and science. So there's no fixed values that you can use it from the day one itself. So you have to go through the iterations. The production gap, yeah, this is always a challenge, right? So it performs well in testing, but once you go into the real world, then you could face a lot of issues. Model degradation and drift, so it could perform well for 1 or 2 months or 3 months or 6 months. Then it start drift and the degradation of the overall model output could decrease. Cost and version control, yeah. So again, if you running multiple models and you want to save them different versions, right, it's going to be expensive. So brand voice and security. So consistently, it is following the organization's ethos and principles is in itself is a task, right? So that is the reason most of the models that are there in production, it has a separate validation check every day before it is run, right? So there is a validation check that is run. So if it's a Q&A bot, you'll spend some 100 questions, and it is giving the same kind of an answer in the context, right? So that's you need to do consistently. And these are some of the learnings that people had, right? So quality over quantity, which we already discussed, right? A small clean data set beats a larger messy one. So if you find out some specific weakness for some of the questions, right, that you're asking, then you need to load it with some more specific examples. So tune your tuning method. So here, since the data set is very low, we used LoRA, but generally the standard is that we need to use QLoRA, actually, quantized LoRA. So specificity is a trade-off. So making a model an expert in one area can make it worse in others. So here you're giving an LLM legal contracts, right? So it may be able to brilliant at drafting clauses, but when you ask what is the weather like, then it might give you a blank answer. So, but if you ask a lawyer, right? I mean, a human lawyer, he is able to draft those clauses very well, but he's also able to answer what is weather like without any second thought, right? So that kind of a generalization, right? The day-to-day task that we do, right? It may not be able to do if you are trying to do that specificity too much. More training isn't always better, so you have to have that fine balance. When you need to increase your training data set, when you need to stop it. So underestimating the vibe check. So fine tuning is the best way to make it a specific personality or format. So if you want a humor in each and every of the sentence that it is displaying, right? So you need to tune it that prompt in a humorous way, right? So that way it will learn that kind of an answer style. Okay. So this is a conclusion, right? So fine tuning is a powerful technique for transforming general purpose to LLM to specific experts, and you can train it for to get the deep domain knowledge. So success depends upon a clear objective and high quality data and choosing the right method for your goals.